present here a project called LUVMI, which is a project funded in the Horizon 2020 program in the space call of the Commission. And this deals actually with a planetary rover development that can carry some instruments to perform science on the moon. We want to be able to bring a technology that can help detecting whether there is water ice on the south pole of the moon. This is a challenge which is, let's say, very much trendy for the time being in the space agencies in Europe, in different countries in Europe, and also in everywhere else in the world, in Japan, in the States. This is something of high interest. And LUVMI is a relatively small platform, about 40 kilograms, and this makes it a little bit unique because this should allow bringing with a much more affordable mission these technologies on the moon to analyze the floor and find if there is indeed some scientific interest with the regolith, which is the sound you can find on the moon. And so the platform you can see here has 4 wheels and an active chassis that can be lowered to bring a driller very close to the floor, and that's what allows analyzing the volatiles, so which is what you can extract from the soil. There's a so-called mass spectrometer, which is an instrument that analyzes indeed what are the chemicals, and that helps eventually finding if there is some water in the floor of the moon. So these, let's say, will bring some new technology. We would like to fly that in 2020 with a real mission. And we bring also on the top of the mast a camera. We want also to be able to bring some nice pictures from the place. It's very important for outreach, for education. We could already bring some, say, high interest in the community and in the general public also. That's what we hope. And so this project should also contribute with that respect to both science, education, and developing technologies. We are an SME developing parts of this rover. You can see here, for instance, a 1-to-1 scale wheel that we developed really for this rover. This is a plastic one. The real one will be in aluminum, and metal sheets technologies are used to develop it, which makes it, in principle, lightweight and still making it quite stiff and robust for this type of application. So that's for it. I hope you enjoy the presentation.
All right, then what you see here is basically a simulation. It's the prototype that we plan to build. We have assembled the CAD model and then we've put it into a simulation. That way we can have an overview about how it will look. And in this demonstration, basically what we use is a head-mounted display that I'm able to wear. And as soon as I wear it, I will see what you see on the screen here, and I will be able to move my head and see freely around. So right now you can see I'm looking at the Earth, and then basically I can move back and look at the rover, move around, etc. And so the fact is that with such an active screen, you can look more closely and have something which is more natural to any user. If you like to come.